Yeah, good evening all. Now I am going to explain about some more questions on power systems. Okay, 46th question. A high voltage DC testing for HV machines is resorted because option A, certain conclusions regarding the continuous aging of an insulation can be drawn. That is first answer, that is correct. Next, the stress distribution is a representation of the service condition. That is not correct. Third option, standardization on the magnitude of voltage to be applied is available. That is also not correct, right? Fourth one, the stress do not damage the coil and insulation. That means first answer, that is certain conclusions regarding the continuous aging of an insulation can be drawn. Okay, that is about 46th one is A is correct. Next, 47th one, for a lumped inductive load with increase in supply frequency. Okay, in case of inductive load, okay, the reactive power Q suffix L is depends upon I square into XL. Okay, that is reactive power is directly proportional to I square into XL. XL is nothing but 2 pi FL, right? That means when frequency increases, reactive power generation is increases. When reactive power generation is increases, active power generation is reduces. That means 47th answer is option C is Q is increases, P is decreases, right? That means third option is correct. Next, standard impulse testing of a power transformer requires. Okay, the standard impulse testing of a power transformer requires two applications of chopped wave followed by one application of a full wave. Okay, remember direct question, this is remember the answer, two applications of chopped wave followed by one application of a full wave. Okay, that is about 48th question. Next, 49th question, the supply voltage V in the diagram shown below is. Okay, what is given? Voltage across resistor is 40 volts is given, voltage across inductor is 70 volts is given, voltage across capacitor is 100 volts is given. Then in case of AC circuits, total voltage V is equals to under root VR square plus, here VC magnitude is greater than VL, right? That means under root VR square, that is 40 square plus 100 minus 70 whole square. Okay, now see the answer here. Total voltage V is equals to under root VR square plus VC minus VL whole square, right? Here VC magnitude is greater than VL, right? Then VR value is given as 40, that is 40 square plus 100 minus 30 whole square, that is under root 40 square plus 70 square. 40 square is nothing but 1600, right? Next 70 square is nothing but 4900, right? If you simplify that equation, you will get 50 volts is the answer. Okay, then 50 volts is nothing but which option? Third option is correct. Next, question number 50, the chance of arc interruption in subsequent current zero. Okay, in subsequent current zero, in case of oil circuit breaker it is increases, that means increases in case of oil circuit breaker. Okay, in case of air blast circuit breaker decreases. Okay, now see here, first option is increases in case of oil circuit breaker, that is correct. Okay, that is 50th answer will be first one. See the answer, 50th answer is first one, that is correct. Next, 51st question, the chance of arc interruption in subsequent current zeros. Okay, already we know first point, right? Increases in case of oil circuit breaker, right? But decreases in case of air blast circuit breaker. In previous problem only I explained this point, right? Now see here, second option, decreases in case of air blast circuit breaker and increases in case of oil circuit breaker. That means 51st question answer will be B is correct. Next, the velocity of traveling wave through a cable of relative permittivity 9 is. Okay, the velocity of a traveling wave for overhead lines is constant, that is 3 into 10 to the power 8 meters per second, or 3 into 10 to the power 5 kilometer per second, both are same. Okay, but in case of underground cables, the velocity of traveling wave is depends upon relative permittivity. Okay, then the velocity of traveling wave formula will be v is equals to 3 into 10 to the power 8 divided by under root epsilon r, where epsilon r is relative permittivity in meters per second, or in terms of kilometer per second, that is 3 into 10 to the power 5 by epsilon under root epsilon r kilometer per second. Now see here epsilon r value is given as 9, right? Root 9 value will be 3, that is 3 into 10 to the power 8 by 3, you will get 10 to the power 8 meter per second, or 10 to the power 5 kilometer per second, right? Then from the given options, first one is 9 into 10 to the power 8 meters per second, that is not correct. Second option 3 into 10 to the power 8 meters per second, that is also not correct. Third option is correct, right? That is 10 to the power 8 meter per second. Next, an overhead line with a surge impedance of 40 ohms is terminated through a resistance R full stop. A surge traveling over the line does not suffer any reflection at the junction if the value of resistor is. Now see here, in case of traveling wave analysis, okay, here ZC is given, right? ZC is 400, that is line impedance is given as 400, right? Okay, what is given? There is no reflection takes place. Reflection takes place when impedance is changes. At any point, at any junction, impedance takes place, then only reflection and refraction takes place, right? That means here there is no reflection takes place means no change in impedance. That means whatever the impedance present in source, that means whatever the line impedance is present, that impedance is equals to the load impedance, then only no reflection takes place. That means when ZC is equals to R, then only no reflection and no reflection takes place. That means R value here, R value is 400 ohms is correct. That means first option is 20 ohm, that is not correct. Second option 200 ohms, that is also not correct. Third option is 800 ohms, that is also not correct. That means none of this is correct. Okay, next, the rate of rise of restriking voltage is depends upon, okay, the rate of rise of restriking voltage, that is nothing but triple RV is equals to Vm by under root LC into sine omega n into T. See here, the rate of rise of restriking voltage formula will be Vm into omega n into sine omega n into T, where omega n is nothing but 1 by root LC. That means rate of rise of restriking voltage is depends upon inductance value and capacitance value, right? Now see the options. The rate of rise of restriking voltage depends upon type of circuit breaker, that is not correct. Second option only inductance, okay, inductance is correct, but only inductance is not correct, right? Next, the capacitance of the system only, that means that is also not correct. Fourth option, the inductance and capacitance of the system, right? From the given formula, rate of rise of restriking voltage is equals to Vm by under root LC, right? That means that is depends upon inductance and capacitance value, right? That means fourth answer is correct. Next, gas turbine can brought to the bus bar from cold in about around 2 to 3 minutes. That is first option is correct. Next, a three-phase breaker is rated at 2000 MVA, 33 kilovolts. Okay, its making current will be, okay, the making current formula is 2.55 times of symmetrical current. Okay, making current is equals to 2.55 times of symmetrical current. First we need to calculate symmetrical current. First, from the given problem, what is given? Rating is given, okay, that is S is given, right? Next, line voltage is given VL. Then S is equals to formula will be root 3 into VL into IL. Here IL is nothing but symmetrical current. See here, given data 2000 MVA is nothing but S, VL is line voltage 33 kilovolts. Then symmetrical current, making current formula will be making current is equals to 2.55 into I symmetrical. Okay, then to calculate symmetrical current we need to use formula S is equals to root 3 VL I symmetrical. Then I symmetrical is equals to S by root 3 into VL, right? If I simplify that one, symmetrical current is 35 kilo ampere. Okay, after that making current is equals to 2.55 into 35, you will get 89 kilo amperes is the current. Now see here, from the given options, first option is 35 kilo ampere. See here, if you forgot to calculate 2.55 into I symmetrical, then first option is correct, but symmetrical current for making current formula is 2.55 times of I symmetrical. If you calculate only symmetrical current, that is also there in the option, right? Careful about this type of problems. Okay, second option 49, that is also not correct. Third option is 70, right? Fourth option is 89 kilo amperes. That means fourth option is correct. Next, 57th question. If a combination of HRC fuse and circuit breaker is used, the circuit breaker operates for, okay, always it operates for low overload currents. That means first option is correct. Next, 58th question. The impulse ratio of a gap of given geometry and dimension is, the impulse ratio of a gap of given geometry and dimension is, okay, that is greater with solid than with air dielectric. That means first option is correct. This is also direct question. Next, 59th question. Tick out the correct one. The insulator and lightning arrestor should have high impulse ratio. Next, the insulator and lightning arrestor should have low impulse ratio. And the insulator, third option is the insulator should have high impulse ratio and lightning arrestor have low. That means third option is correct. Next, 68th question. Phase modifier is normally installed in case of, okay, phase modifiers are normally installed in case of long transmission lines. Okay, next, 61st question. Series compensation on EHV line is resorted to. Series combination means always to improve stability. That means 61st question is option A is correct. Next, Ferranti effect on overhead lines is expressed when it is, Ferranti effect is predominantly on under normal light load condition only. That is 62nd answer is also A. That is also a direct question. Next, 63rd one. Stringing chart is useful for the sag calculations. For sag calculation purpose only, stringing chart is useful. That means first option is finding the sag. That is correct. Okay, that means first option is correct. Next, the presence of earth in case of overhead lines. The presence of earth in case of overhead lines. Okay, because of presence of earth, that means it will form a capacitance. That means it will increases the capacitance. That means 64th answer is A. Next, 65th one. For an existing AC transmission line, the string efficiency is 80%. Now if DC voltage is given or supplied for the same setup, the string efficiency will be, now see here, if DC voltage is given, okay, no mutual capacitance is exist, right? Hence voltage across, for example, let us consider 3 discs. Okay, the voltage across each disc will be V1, V2, V3. All voltages will be equal. That is V1 is equals to V2 is equals to V3. Okay, then the efficiency, string efficiency formula will be voltage across the string is nothing but V1 plus V2 plus V3, that is equals to V plus V plus V, right? That is 3V divided by n is nothing but number of discs, that is 3, into voltage across the disc nearer the conductor V3, that is also equals to V. Then if DC voltage is given, blindly remember the string efficiency will be 100%. Okay, thank you all. Remaining we will see in next class.